6 functions, 1 Python process, full control of your Mac, browser use just open-sourced macos-harness, and the surface area is so thin it should make you nervous, in both directions. On August 17th, Gregor Zunich, founder of Browser Use, pushed 0.1.0 through 0.1.2 of macos-harness to GitHub. It is a minimal Python process that gives an AI agent 6 primitives to control macOS. mac.c for screen capture, mac.key for keyboard input, mac.type for text entry, mac.click for mouse, mac.ax for the accessibility tree, and mac.script for AppleScript and shell execution. That is the entire public API, a few hundred lines of Python wrapping the OS directly. No heavy orchestration layer, no proprietary SDK, just a persistent process sitting between your LLM and your desktop. 2 architectural decisions make this interesting. First, PID-based targeting. The agent addresses applications by process ID, not by active window focus. That means it can read and interact with a background window without stealing your mouse or yanking focus away from whatever you are doing. There is a click-through virtual cursor. Your physical mouse stays yours. Second, mid-task self-extension. The agent can write its own auxiliary Python functions during a run and call them immediately. So instead of a brittle, hard-coded wrapper for every app, the LLM writes the glue code on the fly when it hits something unexpected. That is a meaningful shift. From a framework you configure ahead of time to a code loop the agent extends at runtime. The sourced competitive landscape here is thin, so I will only speak to what is documented. 2 peers worth knowing about. Osaurus is a native macOS agent harness written entirely in Swift. It ships its own local inferencing engine, persistent memory, and cryptographic identity. That is a very different philosophy. Deeply native, opinionated, batteries included. macos-harness is the opposite. Python, minimal, bring your own model. If you want to bolt this onto an existing LLM pipeline in an afternoon, macos-harness wins on friction. If you want a self-contained agent runtime with memory and identity baked in, Osaurus is the comparison to make. Then there is Wake, which is a Claude code session manager and transcript harness for terminal coding agents, local first, open source auditing. Wake is more adjacent than competitive. It lives in the terminal coding lane, not the full desktop UI lane. No sourced benchmark head-to-heads exist between these 3 as of this brief. Here's where the architect brain kicks in. Thin surface area does not mean small blast radius. It means the opposite. MacScript gives the agent arbitrary shell and AppleScript execution. MacAx gives it the full accessibility tree. Any text the agent reads on screen, a web page, a notification, a document, is untrusted input that can redirect the agent loop. Prompt injection here is not a data leak. It is remote code execution on your local machine. That is the threat model you are accepting. The open questions, the brief flags are real. There is no documented sandboxing strategy for isolating runaway behavior without breaking the native UI hooks the harness depends on. And mid-task modal dialogues, a system permission prompt, a crash reporter, an app update nag, the harness does not have a documented recovery path for those yet. This is v0.1. That is not a criticism, it is a calibration. Who should actually care about this right now? If you are building a desktop automation pipeline, and you have been fighting a heavy orchestration framework that breaks every time an app updates its UI, macos-harness is worth a serious look. The PID targeting and background capture alone solve a real pain point. If you are evaluating this for anything that touches production data or runs unattended on a machine with credentials, you are not ready yet, and neither is the harness. The sandboxing story needs to exist before that conversation happens. My Monday take: clone the repo, run it against a throwaway app in a VM or a dedicated test machine, and stress test the modal dialog failure mode yourself. Do not deploy this adjacent to anything sensitive until there is a documented isolation strategy. Watch list for production, immediate experiment for research and internal tooling. macos-harness is a bet that the right abstraction for desktop agents is almost no abstraction. 6 primitives, 1 process, and an LLM that writes its own helpers when it gets stuck. That is an interesting architectural argument. The failure modes are real and the sandboxing story is unwritten. Both of those things can be true. Full source breakdown and citations are in the description. Subscribe if you want the next systems brief when it drops.